Okay, so today we are going to talk about 6.1 polygon angle theorems. You should know, because of what we have worked with, that if you have a triangle, let's make this a right triangle. If this is 37, then how do I know what that missing angle is? And that is because these are complementary, which means that these two have to equal 90 degrees, which means that this missing angle is going to be 53 degrees. So we know that all triangles, interior angles, equal 180. We know that. And I think that we could figure out how much also. Let's make it a rectangle. So in a rectangle we have 4 right angles. So 4 times 90 gives me 360. That is going to be true for all quadrilaterals. So that is where we're going, is we're going to figure out the angle sums, the interior and the exterior of a lot of different kinds of polygons. So let's first of all, let's go through the names of the polygons. You have to have 3 sides. So if you have 3 sides, that particular polygon is called a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 is a hexagon. 7, this isn't used very often, but it is a heptagon. 8 is an octagon. 9, again, not used very often, but it is a nonagon. We'll go up to 12. 10 is a decagon. 11 is an or an undecagon. Now also keep in mind that some of these oddball ones, like 7 and 9 and 11, you might see different names for those. It kind of depends on the textbook. And 12 is a dodecagon. So if I give you a problem, I'm talking about a dodecagon or a nonagon, you should be able to tell me how many sides those actually have. Once we get to 13, we just call it a 13gon, 14gon, blah blah blah, 35gon. So after we get to 13, we just call it gon. So we need to know how we can find out, without going through all this, but there is a formula for how to find the measures of an interior, sum of the interior angles. So the sum of the interior angles of a polygon where n, small n, is the number of sides, it would be that the sum equals 180 times the quantity of n minus 2. So the sum equals 180 times the quantity of n minus 2, again where n is the number of sides. So if I'm looking for the sum of the interior angles of a nonagon, I would say the sum is 180. Number of sides is 9 minus 2. And so 180 times 7, then, take out my handy dandy calculator, and you get that the sum would be 12 160. And we are talking about degrees. Oopsie. Okay? So that is how you would use that formula. There are different types of polygons. There is one that we typically call equiangular. That is a polygon with all congruent angles. We have equilateral, which is a polygon with all congruent sides. And then we have what is called a regular. It is a polygon that is both equilateral and equiangular. Okay, so when we think of our typical stop sign, okay, not a very good one, but all of the sides are going to be congruent and all of the angles would be congruent. Therefore, that would be called a regular. There are certain ones that we have special names for. If we have a regular triangle, we would call it usually equilateral triangle. If we have a regular quadrilateral, we would call that a square. And then once we get up to 5 and 6 sides, we would just call it a regular pentagon, regular hexagon. Okay? So if we are doing some of these problems, we would want to know how to find the measure of one angle. So if the sum equals 180 times a quantity of n minus 2, then how or what would be the measure of one angle in, just to go back to our previous example, in a regular nonagon. Okay, so from previous, we found out that the sum in the nonagon is 1260, but I want one angle. So I would find out that one angle then would be 1260 divided by the number of sides. Divide that by 7. So that would mean that each interior angle would equal not times 7, times 9 in a nonagon. Oh my goodness. Jeez. That each interior angle would equal 140 degrees. Another thing we're going to talk about quickly is the exterior angles, or the sum of the exterior angles. This should be a fairly easy one because they always equals 180 degrees. Always, no matter how many sides angles that you have. So if I have a parallelogram, for example, the way that you find the exterior angles is to extend a side out, so this would be 60, 120 because these are a linear pair, 60 again linear pair, and 120. So if I add all those up, I do not get 180. I get, fix this please, 360 degrees. So 120 plus 120 plus 60 plus 60 gives me 360 degrees. Okay, so the sum of any polygon's exterior angles gives me 360 degrees. I want you to try 3 problems for a warm-up for tomorrow. So this would be activity or practice 1. I want you to find the sum of the interior angles of a 11-gon. Activity 2, I want you to find the sum of the angles. Let's make that exterior angles of a 15-gon. And then last activity, activity 3, find the measures of an interior angle and an exterior angle of a regular decagon. Be careful with some key words here. And so come to class tomorrow with those 3 practice problems completed so that we can look and see how you did.